Hello, I'm Deepak. Along with my colleagues from CHSA, as well as the coordinating team from Addo High School, we welcome you to the Physics Teleclass for Grade 11. As per the Edexcel AS Physics, there are three units to study in Grade 11, which are Units 1, 2, and 3. Among these, we will be starting with Unit 1, which can be further classified into two broad topics. The first is mechanics, which includes kinematics, dynamics, etc. And second is materials, which includes fluids and solids. Today's class will be focused on physical quantities and units. Before we delve into the lesson, let's have a look at the frequently used terms. The first is physical property, which is defined as a measurable property of something observable without having to change the composition or identity of that thing. It means that if we can measure something that can be seen or felt or detected, then that is called a physical property. Next is quantity, which is something that can be quantified. For example, if there is a bag which has 5 chocolates, then 5 is the quantity. Now, if we combine the above mentioned terms, we get physical quantity. It can be defined as a physical property which can be expressed as a combination of size and unit. In the example mentioned, length is given as 13 centimeters. Here, 13 is the size and centimeters is the unit. Sometimes, instead of size, magnitude can also be used. Physical quantities can be divided into base quantities as well as derived quantities. The units for base quantities are expressed in base units, and that of derived quantities are expressed in derived units. Even though there are 7 base quantities, as per our syllabus, we will be limiting that number to 6, and thus we will learn about 6 base units. When we talk about units, there are different systems of units in use today. Among these, the two widely used systems are: first one, the International System of Units, or commonly called as SI units, which has the units such as meter, kilogram, second, etc. Then we have British International System, also called as Imperial System of Units, which has units foot, pound, seconds, etc. The table here shows the base quantities and units, along with their symbol and abbreviation. Length, the symbol is L, the unit is meter, and the abbreviation is small letter m. For mass, the symbol is small letter m, the unit is kilogram, which is represented by small k and small g. Time, the symbol is small t, the unit is seconds, and the abbreviation is small letter s. For electric current, the symbol is capital I, the unit is ampere, and the abbreviation for that is capital A. For thermodynamic temperature, the symbol is T, although in some of the texts or some of the syllabus you come across when you go for higher studies, you will see that instead of T, sometimes theta is also used. But for now, we can stick to the symbol being capital T. The unit is Kelvin, and the abbreviation for that unit is capital K. The amount of substance, its symbol is small letter n. Unit is mole, which is M-O-L-E, E at the end. And the abbreviation for that unit is also mole, but there is no E at the end. Derived quantities are obtained by combining base quantities, and due to this, derived units are defined or written as product of powers of base units. For example, area is the product of two lengths, so its base unit will be meter square. And speed is defined as distance over time, so its unit will be meters per second. Sometimes it's difficult to express the complete unit in its base units, so we have come up with different names. The units like that for example, are newtons, Pascal. Even though when you write that in base units, it's a lot. So we call it by different names. Before we progress further into the lesson, there are some mandatory math skills that you are required to know. The first is the way in which you will be writing the units. So first is about the units. For example, let's take the example of speed, which the unit is meters per second. For acceleration, the unit is meters per second square. And for density, that is kilogram per meter cube. So this is how you have learned the representation of units in previous grades. Like you write a slash, so instead of meters per second writing like this, or you may have learned it like this. Now the thing is, we will not be representing the units like this from now onwards. So before that, you need to know, if you write 1 by a, it is same as writing 1 by a to the power 1. Now if I want to bring the denominator into the numerator, the power will become negative. So this is same as writing a to the power minus 1. So if you take speed, which is meters per second, this is same as writing meters per second, which is s to the power 1. And if I want to bring s to the power 1 to the numerator, I get meters per second minus 1. Now, when you take the next one for acceleration, that is meters per second square. So s square goes to the numerator, becomes s to the power minus 2. So this unit I can write as ms to the power minus 2. And the last one is for density, which is kilogram per meter cube. So this can be written as kilogram m to the power minus 3, because m to the power 3 goes to the numerator, becomes the negative. Power will become negative, so you have m to the power minus 3. The reason we write this way is when you go deep into the physics lessons, there will be some units where you have to write many things by drawing slash, which is not practical to write like that. So what we're going to do is we will write everything in the numerator, where the powers will be plus or minus for the variables. The second set of the required math skill is about multiplying variables. For example, if you multiply m to the power 1 times m to the power 2, though let's say you came across a simplification pattern like this, where you had to multiply m to the power 1 times m to the power 2. So here you can see that the base is same for the variable. So as per the lesson of indices, when you have the variables of same base being multiplied, you can add the powers. So I can rewrite this as m to the power of 1 plus 2, I get m to the power of 3. So if you multiply m times m square, you get m cubed. Then another example being, let's say, t to the power of 5 times t to the power of minus 3. Again, you can see that the base is same, so you can add the powers. So you have 5 plus minus 3. You get t to the power 5 minus 3, which is t to the power 2. Again, this is required when you write when you write the units in detail later. The table here shows some of the derived quantities and units. The first one is area. The expression is length times breadth, and the unit is meter square. For volume, that's area times height, the unit is meter cube. Velocity is displacement over time. For displacement, that is meters. For time, it's seconds. So it's meters per second. And here you can see that instead of writing m slash s, it's written as ms to the power minus 1. For acceleration, again you can see the unit being written as ms to the power minus 2 rather than meters per second square. And you will see some other examples also mentioned here. If you look at force, the base units is written as kilogram ms to the power minus 2. So when you write the unit of force in this manner in terms of the base units, it's very difficult to say that all the time. So we have another unit, Newton. So we usually use Newton as the unit of force. So when you go here, we'll be learning how to convert a derived unit into base units. Sometimes there will be a situation where you have to compare different quantities. And the easiest way to do that is comparing their units. Because if the units are same, then you can say that they represent the same physical quantity. Again, the problem is when you have to compare a derived unit which has some special names. For example, if you want to compare Newton and Pascal, there are two different variables. You cannot compare them. So the best method to do that it is to convert those derived units in the base units. So when you break down Newton or Pascal in the base units, if they are of the same nature, then you can say that the units are same, which means the quantity is same. And here we look at the way that could be done. The example given is force, and the unit of force is Newton. So in order to convert Newton, which is a derived unit, into base unit, the first step is to figure out which formula can be used to represent that unit. So Newton is for force, and force can be written as product of mass times acceleration. For mass, it's kilogram. For acceleration, it's meters per second square. So the Newton can be written as kilogram ms to the power minus 2. The next example is for energy. And for energy, the unit is joules. So when you look at the formulae for energy, there are plenty available. So on the left hand side, I have used the formula for energy specifically for gravitational potential energy. And on the right hand side, I have used the formula for kinetic energy. So if you look on the left hand side, I have used the formula for gravitational potential energy, which is m times g times h. M is mass, h is height. G, there are two names. You have gravitational field strength, which is given in newtons per kilogram. Or you can say G as acceleration due to gravity, whose unit is meters per second square. And since this topic is only related to units, I'm going to use the simplest one. So I will take G as acceleration due to gravity. So when I look at the units, you have kg, which is for mass, meters per second square for acceleration due to gravity, and meters is for height. So here, m and m are being multiplied. Since they are same powers, you can multiply them. So m times m will be m square. So the final answer for joule, that it will be kilogram meter square s to the power minus 2. When you go on to the right hand side, the formula I'm going to use is half mv square. And when you look at the units, what you have to remember is only physical quantities will have units. So half is a fraction, which means it's not a physical quantity, so it won't have any units. So you can forget about the units of half. So what left is mass as well as the velocity square or speed square. For mass, it's kilogram. For speed, that is meters per second to the power minus 1 square. So when I expand the brackets, I get kilogram m square s to the power minus 2. So here you can see that it doesn't matter which path or which formula you follow. At the end, if it is the same physical quantity, if you write everything or if you write the units in its base unit, they must give the same answer. Now we have some questions where you have to find the base unit of the derived units. The first question is Pascal. So by following the steps mentioned in the previous slide, the first part of that will be to find out which quantity is represented by Pascal. So Pascal can be represented or is used to represent pressure. And when you look at different formulae of pressure, the easiest one of that will be P equals F over A. And this is the easiest formula where P is pressure, F is force, A is area. So for force, the formula is M times A. So when I write the units, I get for mass, that's kilogram. For acceleration, that is meters per second square. So for force, I can write this as kilogram ms to the power minus 2. For area, that is length times length, or length times breadth, or just the product of two lengths. So I can write L times B. So when I write the units, this is meters. I'm going to write the units here. And this is also meters. So when you multiply them, what you get is meters square. So when I substitute the two base units back in the formula, I get Pascal. It's same as writing force, which is kilogram ms to the power minus 2 divided by meter square. Now, as I mentioned before, you won't be writing anything in the denominator. So I want to bring m square up. So I get kilogram ms to the power minus 2. M to the power 2 goes to the numerator, becomes m to the power minus 2. Here you can look at the variables. They are of same base, so the powers can be added. It will become m to the power 1 plus minus 2, because this is 1 here, minus 2 here, s to the power minus 2. So the final simplification will be kilogram m to the power minus 1, s to the power minus 2. So this is how you write Pascal in its base units. The next question is to calculate the base unit of the derived unit watts. By following the same procedure, we have to watts is representing power, and for power I'm going to use the equation energy over time. So energy over time, energy, the unit is joule. For time, it's seconds. So when you look at the numerator, joule, it's not a base unit. So we need to figure out how to convert joule into base units. So for energy, you need to pick any formula for energy. I'm going to use the gravitational potential energy equation. So energy can be written as m times g times h. When I write the units, I get for mass, that's kilogram. G, I'm going to take it as meters per second square because it's acceleration due to gravity. And for h, that is meters. So m and m can be multiplied. I get kilogram m square s to the power minus 2. So this is for joule. For time, it's seconds. You don't need to change that because it's one of the base units. So when I put the kilogram squares to the power minus 2 back into the equation, you have watts that equals for energy. Joule, I'm going to write kilogram m square s to the power minus 2 divided by s. And we won't be writing anything in the denominator, so I want to bring s back to the numerator. This becomes kilogram m square s to the power minus 2 times s to the power minus 1. This becomes kilogram m square. The base is same, so you can add the powers. So s to the power minus 2 plus minus 1. So this is for s. I get watts as kilogram m square s to the power of minus 3. So this is how you will be writing watt in the base units. So with this, we have concluded today's class, the first part of physical quantities and units. And this lesson is very much required for what will be carried on to the next one. So I hope you have understood what I taught. Thank you.